Hello everyone. Okay, today we will discuss the JEE advanced numerical, okay, in PIQ from the chapters electrostatics, right? So you will see that on the screen the question is here. What are the question? The question is a small electric dipole P naught having moment of inertia I about the center is kept at a distance smaller from the center of a spherical shell of radius capital R. The surface charge density sigma is uniformly distributed on the spherical shell. The dipole is initially oriented at a very small angle theta, okay, and if it is released at a distance r, then there are four options, okay, and for the four option which is valid. So this is our goal, okay. Now before discussing but before doing this problem, now we will draw I will draw the figure here. So what are the figure? The figure is like that, okay. So this is our spherical shell, okay. According to question, this is the center O, right, and this is radius r, okay. Now from the center of the spherical cell, so this is the center, from the center of the spherical cell at a distance smaller, so these are the distance very small r, right. A dipole is kept of dipole moment p naught. So this is the dipole, right, and this is the dipole, and this dipole makes an angle theta, and this is p naught, a dipole, right. This is given. So now our goal is if the dipole is freely released, okay, then from the four MCQ types questions, which is valid, which is correct, okay. Now charge is distributed, the charge is distributed over the surface is capital Q, okay. So now we know if the charge is distributed over the surface, the spherical charge density sigma, the surface charge density sigma. What is the value? Sigma is total charge by total area 4 pi r square. What is the area? 4 pi r square. From this equations, capital Q charge is equal to sigma into 4 pi into r square. Now we got the total charge Q here. Now we also know if the charge is there surrounding it, okay, an electric field will be developed. So what are the electric field? Now the electric field at a distance smaller is the electric field at a distance, right, at a distance small r. What is the electric field is equal to 1 over 4 pi epsilon naught q by r square. So electric field E is equal to 1 over 4 pi epsilon naught into q by r square. Now we put the value of the q. What is the value of q? Q is equal to 1 over 4 pi epsilon naught, right, into sigma into 4 pi into r square. Now we will simplify it. So E is equal to sigma 4 pi is cancelled into r square by epsilon naught. Okay. Now we have seen, but we know when a dipole is placed or kept in an electric field at angle theta, then there will be torque. So what is the value of the torque? Torque tau is equal to P cross E, right? As the dipole is kept into the electric field, so there will also be a torque. So the torque generated, the torque due to the electric field, but due to the dipole in an electric field, is tau. What is the value tau? Tau is equal to P vector cross E vector, right? So this means P into E into sine theta, okay. So this is equation number 2, this is equation number 1. Now we'll put the value E in these equations. Okay. So tau is equal to P. P means P naught, right? This is P naught. P naught. What is the value of E? E means sigma into R square by epsilon naught into sine into theta. Right? Again we know the tau is equal to minus I into alpha for this. Okay. Now put this value. Now we know the tau is equal to I alpha. Tau is equal to I into alpha. Tau is equal to I into alpha, right? What is the value of the tau? The value of the tau is, from this equation, alpha is equal to P naught, right, into R square into sigma by epsilon naught into small r square into alpha. Okay, this is minus, okay, into sine theta. There is a sine theta term, there also sine theta term. Okay, if theta is very small, then sine theta can be written as nearly equal to theta. Okay, so alpha is equal to minus P naught into R square into sigma into theta by epsilon naught into R square. Okay, again we know alpha is equal to minus omega square into theta. Okay, so these equation and these equations similar. What is omega? Omega is angular frequency. Now we will compare these equations and these equations, right? So omega square is equal to minus P naught into R square into sigma by epsilon naught into R square, right? From this equations, omega is equal to square root of P naught into R square into sigma by epsilon naught into R square. Now we will consider the four options here. The first option is small number 1a. What is R less than capital R? If R less than capital R, that means inside the spherical cell. So inside the spherical cell there is no electric field. If there is no electric field, no angular accelerations, right? So this as electric field is equal to 0, so the first option is not valid. Okay, second option is R greater than capital R. This equation is already valid, right? Third option is if small r is equal to 2r, right? Now we will put the value small r is equal to 2r in these equations. Okay, then is equal to, when r is equal to 2r, then omega হচ্ছে p naught into r square into sigma by epsilon naught into 2r তার whole square, right? So already 2r square is cancelled, so thereby p naught into sigma by epsilon naught into 4 into I. So this is option number C is also not correct. Now option number 4. What is option number 4 or D? This if R is equal to 10R, okay, then omega is equal to P naught into R square into sigma, right, into epsilon naught. So here we will put a value R is equal to 10R, right, 10R whole square into I. Now see, omega is equal to P naught into R square into sigma by epsilon naught into 100 into I. So this is valid. So from this questions there are four options. Only option number B and option number D is correct. So this is JEE advanced PUK question, very important question and one of the tough question. Okay.